need to store data temporarily, but don't want to deal with databases or external services. We'll see how FastMCP's built-in in-memory storage works, using just 2 lines of code to create a lightweight key-value store that's perfect for development and testing. You'll also learn when this simple approach is enough, and when you'll need to switch to something more persistent.
From py-key-value-aio stores, memory import MemoryStore. Hash used by default, no configuration needed. Hash, but you can also be explicit. Cache store equals MemoryStore.
This demonstrates the strategy pattern applied to storage backends, where interchangeable implementations share a common interface. The key concept is abstraction through a unified key-value interface, allowing you to swap storage mechanisms without changing application logic. What makes this distinctive is the complete decoupling of business logic from persistence details, enabling runtime configuration of where and how data is stored. The pattern works by defining a contract for storage operations while delegating the actual implementation to pluggable backends. FastMCP uses py-key-value-aio as the abstraction layer, which provides consistent async operations across memory, disk, Redis, and other systems. This creates a clean separation where your application code interacts with a generic store interface, while the specific backend handles serialization, networking, or file system operations transparently. This approach solves the classic problem of environment-specific configuration without code changes. You can develop with in-memory storage, then switch to Redis for production by changing just the initialization. The trade-off is a slight abstraction overhead, but the benefit is deployment flexibility and the ability to optimize storage independently from your core logic. It's particularly valuable for systems that need to scale from local development to distributed cloud deployments. Let's break it down line by line.
From py-key-value-aio stores, memory import MemoryStore.
This imports MemoryStore, an in-memory key-value cache implementation. It's the default store when no configuration is provided, ideal for development and testing where persistence isn't required.
Hash used by default, no configuration needed. Hash, but you can also be explicit. Cache store equals MemoryStore.
This demonstrates the zero config default pattern. MemoryStore is the in-memory cache backend automatically used if no store is specified. Explicit instantiation here shows how to override defaults when needed. Memory storage pattern. The MemoryStore demonstrates FastMCP's pluggable storage architecture, where in-memory caching provides zero configuration development while enabling seamless upgrades to persistent backends. Memory stores vanish with process termination, making them unsuitable for production state management. Always wrap sensitive storage like OAuth tokens with Fernet encryption wrapper before switching to persistent backends.
The cache that remembers nothing becomes the foundation for all memory.